Hello everyone. I welcome you to today's training. Today we are going to look at Python programming for data analysis. So I welcome all of you to today's training. And once again, I thank you for staying for this long up to this time. I really appreciate your efforts and your commitments. As always, I always encourage you to continue staying along and practicing what we learn. Data analysis or data science training, or it's a gradual process. So the more you practice, the more you master. So don't forget to continue practicing along. And don't forget, if you don't understand anything or you have any challenges, you know how to reach me. You can leave a comment. You can also reach to me via WhatsApp or even email. I'll be glad to assist you. Okay, so today we have a lot to look at. That is, we are going to learn Python programming for data analysis. And we will be doing our learning through Jupyter Notebook. So by now, I'm sure you have already downloaded your Jupyter Notebook. If you are having challenge, I'm sure you have an Anaconda. So if you don't have, you are not able to use or you are not able to install a Jupyter, you can use the Anaconda. Okay, so just as a way of starting, let's just walk through how we can, if you have a challenge, how you can install your Anaconda. And so once you open your browser, okay, once you open your browser, all that you need to do is just type Anaconda. So once you search Anaconda, you should see the Anaconda over here, and then you just go to their website. So that is, if you are not able to install the Jupyter, you can use this method and be able to have access to. So once you are here, okay, this is the Anaconda website. You just have to, it says that free distribution. So you just have to scroll and locate where the download is, okay, so that you download your Anaconda. So we have a free download at the top here. Okay, we have a free download at the top here. You just need to click on it. So once you click on it, it should help you start your download. Okay, so we have a free download. Okay. So it should start downloading by now. I don't know. Okay, let's just search Anaconda download and see. So, okay, it's just the same place. So we have okay, yeah. So once you are here, download Anaconda. If you click on download Anaconda, and then okay, it's bringing you to the same place again. So the download should start when you click on the download. So once you finish the downloading, you just need to install it, and then you open. Just the normal installation. You don't have to worry much. You just double click and then you start installing. Another way that you can also use the Jupyter Notebook is through Google Colab. Okay, if you don't, you can also use that through Google Colab. So let's go that. With that one, you just have to type Colab. Okay, so Colab Google. So you go to the collab.google. Good. So once you type the collab.google, it should bring you here. Okay, it should bring you here. And then you just need to click on new notebook. So you just need to click on new notebook. So it will automatically open a new notebook for you. So that is the two-way. So it's either you use the Anaconda or you use the Collab or you use the Jupyter. If you have been able to install the Jupyter successfully, you don't need to worry about this process. Okay. All right. So the Collab note is loading for us. And once it's fully loaded, you should see all your cells inside and should be able to use. Okay, an error. Okay, let's just open the Collab rather. Good. So since this one is giving us error, you can come here and create your new Collab. Okay. So once this one is open, just click on new notebook. So you click on new notebook, you should be able to open your Google Collab and then you start using. And getting another error again. It seems to be running into error with the Google Collab. Okay, so that is the process actually. I'm sure if you try with your own, it should come. I'm running into error with the Google Colab. Anytime I try open a new notebook. So once you are able to open it, all right. Another way that you can also do it, I think you can go to your Google Drive. Okay, you can go to your Drive and then you locate Colab. So let me just open my Google Drive straightforward and then go and open it inside over there. That is one way to good. So once you are in your Google Drive, once you are in your Google Drive, all that you need to do is just need to click on new. Okay. When you click on new, When you click on new, you should see if you see Google Colab as well inside your drive, and then you should launch it. So that is one way to launch your if you want to use a Google Colab. That is one way you can also launch it. Okay. On the other hand, since you have installed you have installed a Jupyter notebook, just have to launch it straight from there. As usual, this is the folder I want to do my work inside, so I just have to launch it from here, and then I'll type CMD and launch it. So it should open CMD for me directly, where I can do my work. Good. So once my CMD is open, I'll just type Jupyter Notebook. So once I type it, just hit enter, and then it will just take a few seconds, and then good, and open. So yeah, my Jupyter Notebook is now open. Okay. Now this file is in the link is in the description. Okay. So the link is in the description. I've already created this. So once you click on the link, it will take you to this particular folder where you have to go and download it. So you go to the Python folder, and then this is this one. So when you open it, here it will open like this for you. It will open like this for you here. So you can download it over here and use. So just click on it and download, and then you have access to it. So that is for this particular one. Okay. Okay. So now that the Jupyter is open like this, for you to start a new, if you want to start a new folder, or you want to launch new, just come and click over here, and then you launch new Python 3. Okay. You have to launch new one. But however, because this one has already been created and is already in your folder, when you want to use it, all that you need to do is just need to double click this one, and it will open in a new tab for you, and then it will open in a new Windows for you. Good. So now we have it open in a new window. We have this particular thing open in a new window. So this is and then that particular one will run. Or you can run cells, select a cell and insert below, or you can run all the above cell. For example, if maybe I've done something up to this particular area and I want to run all the cells above, I'll just need to go there and then go and run all cells above selected cell. Okay, that then it everything, or run all cells and everything will run over here. So that is just a few about them. We also have some keys over here. This one is save as usual. This plus sign is used to create either a new cell, above, okay, or below. Okay, for this particular one, it's used to create below. So if you are in a particular cell, you click on it, click on below, or you can just click on the B on your keyboard and it will create a new cell below, or the A and it will create a new cell above. So that is that. Then we have this particular one. Okay, this one is for the restart the kernel, just like the way over here. The shortcut over here is just here to restart, and this one is just to interrupt it. You want to stop it. This one is to run a particular cell. Okay, and this one you can just use shift and enter and then it will run. So the next thing that we look at is this tab. You can see we have code here, and this particular thing, when you click on it, you can see code and then raw. With the two of them, the two of them that are mostly used is the code and then the markdown. Okay, with the markdown, it's just like, for example, you can see I have some notes here. I use the markdown. So this is the markdown, that is what we use to. In a few moments, we look at how you can create some of these things. Okay, and the code section is for where you write your code. But this particular, as soon as I turn into code, it makes the cell look like a code, and you will see some two square brackets here, which showing that this particular cell is a code, but it's not a code, it's a markdown. So let me just take it off and then run it, and then you can see over here. Okay, so now let's begin and then let's look at some of the introductions. What is Python then? What is Python? We have talked about Python. We've heard of it several times. What is Python? So we say that Python is a high-level versatile programming language known for its simplicity and readability, making it an excellent choice for beginners and experts alike. Okay, Python is such a way that it's very simple and then it's easily to read. You can easily read it, so it makes it the best choice for most beginners and even experts for programming or even data, a lot, web development, data analysis, data science, and so many things. It was created in the 1980s, and then it has become one of the most popular language, especially in the data science, web development, artificial intelligence, data analysis, and automation fields. Those particular fields, it has become one of the most popular language that a lot of people use. Okay, so now we say that Python syntax is easy to read, allowing developers to write and understand code quickly. Okay, it's easy to read. When you see the code, you can easily understand what is happening, and then making it one of the most most language that a lot of developers use. Okay, Python also has a rich ecosystem of libraries, such as pandas for data manipulation, NumPy for numerical calculations, matplotlib for data visualization, and a lot. There are a lot of libraries that you can use when you are dealing with Python. When you are using Python, there are a lot of libraries that you can use to do so many things. So because of that, it's make it universal. It's a lot of people use it. Okay, and then we say, why Python for data analysis? Upon all the languages, why do you choose Python for data analysis? Okay, so we say that Python has become the go-to language for data analysis due to several advantages. And some of the advantages are we have the user-friendly syntax. Python is easy to learn and read, making it accessible to those new to programming. It's easy to learn and it's easy to also read. For example, as we are moving forward, you understand that it's truly easy to understand. Okay, and then it also have extensive libraries. Okay, it has a lot of libraries that you can use to do whatever you want to do easily. So some of the libraries are the pandas, the NumPy, the matplotlib, the scikit-learn, which is for machine learning. Okay, and it also have a strong community support Python has a strong community support, which means that an abundance of resources. Okay, because of its community support, you won't get stuck anywhere. Once you start learning, we have a lot of resources, a lot of tutorials, we have a lot of forums for help and collaborations. If you don't understand anything, they have a lot of forums that you can go. For example, when you go to Stack Overflow, you will get a lot of helps over there. If you are stuck somewhere, as soon as you put your question and then what you are, where you got stuck and what you were doing before you get stuck, you will get somebody to respond to you quickly. So it has a very wide ecosystem of community. And you also say that its integration capability. Python integrates well with other languages and platforms. You can easily integrate Python with other languages, which make it very versatile for a lot of people to use. Okay. Jupyter Notebook. It's a Jupyter Notebook is an interactive web-based environment. Okay, it's an interactive web-based environment or computing platform that allows users to create and share documents containing live code, visualizations, equations, and narrative text. Okay, so you can see Jupyter Notebook. It's because of Jupyter Notebook, I'm able to create this particular note out of it, and I will use the same Jupyter Notebook and create codes that I can share with people, and I can even share these notes with anyone that can easily have access. For example, I've saved it in the GitHub where you can also go and download and then see the same thing of it. Okay, so this has made the Jupyter Notebook very versatile. It is widely used in data science and analytics field because of its cell-based coding with immediate output. Okay, which is perfect for experimenting with codes and visualizing data. Some of the benefits of the Jupyter Notebook include the code and results are shown side by side. So if I write any code, I run it instantly, I see the result of it. So it's like the code is on top, the result is below it, before I can even move on to another code again. So if I'm writing a lengthy code, I don't need to finish all of them before running. Once I run, I'm able to know that, okay, this is a complete code, a one-line code which is complete. I can just run it and get a feedback before I can even move on to the next one. So it makes the code and results side by side. Okay. The second one is the markdown cell lets you add explanations, headings, and notes alongside your code. So you can do anything. You can add explanations because of the markdown nature of it. You can even write your code and then you add explanation. Okay, you can even add headings side by side. For example, you can see I have headings over here. These headings are given, and then we can see I have some of the parts. I've bold them, some I italize them, and so forth and so on. Okay, so that is it. And then you can save and share your notebook, making collaboration very easy. Okay, so the markdown cell in Jupyter Notebook can be created as well. You see this particular one, the last point over, the last bullet over here, I've italiced it. Okay, so it's like the Jupyter Notebook, you can use it as your working document, like Word document. Whilst you are writing your code, then you are documenting the outcomes and so many other things, which make it, after that, you can import it into PDF and other things that you, or HTML that you want to use. That is one thing about it. Now, this is how we can create headings, subheadings and stuff. So this particular cell, let me double click it to select it. So when you want to create markdown, okay, for example, let me just close this particular and create a new cell below. If you want to create a new cell below, just select the cell, make sure that that particular cell is selected. Okay, don't let the cursor be inside, just let it be selected like this. Okay, once it's selected, then you click B on the keyboard, then it will create a new cell below. Okay, if you want to create a cell above, okay, the same to select it like this and then click on A, it will create a new cell above it. Okay, and if you want to delete a particular cell, if you don't like it, for example, I don't like this particular one, I'll just select it. I won't let the cursor be inside. So once it's selected, I'll click D on the keyboard twice. So I'll click D on the keyboard twice. So once I click D on the keyboard twice, it will delete it. Okay, so now let's come here. Okay, so we want to create a markdown. We want to create a heading. Okay, so in Jupyter, once that you create a cell, automatically that cell is a code cell. Okay, it's a code cell. So you see these two square brackets over here. Now I want to turn it to markdown. I just have to go there and then go and choose markdown. So once I choose the markdown, automatically the two brackets is gone. So the square brackets is gone. So now I can type anything. If I type and run, it will become like a note. Okay. So first of all, let's create headings. If you want to create heading in Jupyter, you start with what do you call it? This sign. What do you call it? The hash sign. Okay, you start with the hash sign, and then once you type the hash, the one hash, you then begin to type whatever you want to type. So this, let's say I want to type this is heading. Okay, so once I type this is heading, I can just go to this one and run. So you can use this to run, this button to run, or you can click on shift and enter on your keyboard. So shift and enter and I run it. So this is the heading, and this is the first heading. Okay, if you want to create a second heading, the same thing. The second heading you use double hash. Okay, so two and then second heading, and then I'll run it. So you see that this one becomes smaller than the first one. Now let's come back to this. If you want to create a bullet point, you just use the hyphen and then you give space. Then you create a bullet point. And if you want to create something, you want to bold the text, you put it in 2 stars. And if you want to italize it, you put it in only 1 star. Okay, so that is how it is. Now, if below this one, I want to create a sub bulletin below this one, I'll press my tab before I'll put anything. So I'll say sub. So once I do this, it will create another sub. So let me run the whole of this thing. And then you can now see that I have the first bullet point, second bullet, and then I have a sub bullet point. And this become bold text, and this become what? Italic text. So that is how we create a markdown in Python and in Jupyter Notebook. Okay, so we want to move on with and start with the main business. So let me delete this particular cell. Good. I don't want this one. So now I want to start with this one. The first thing I want to start with is the variable. Okay, I want to start with variable in Python. Okay, so we say that a variable in Python, we say that a variable is a name that refers to a value in Python. So it's a name that refers to a value in Python. Okay, so you when you want to save something, it can be like you want to create a list of something, or you want to give a particular name. The variables is a container. It's kind of a container that hold the name of, or hold a particular value that you want to create. Okay, so let's say that I want to save x. Let's say I want to save maybe the age of a certain student. Okay, so the variable becomes the placeholder. It becomes like something that will hold or will store the data value for me. So for future reference, if I want to reference that particular data value, all that I need to do is to go call that value or that variable name and then to bring it. So for example, let's say I say x, and then once I give the name of the variable, I have to use something we call assignment operator, which is the equal to. So it means that I'm trying to assign a value to this particular variable. So let's say I will say 10. Okay, so and then I'll say y2 is equal to 15. Okay, when I run this, nothing will happen. When I run this, nothing will happen. Nothing is happening because I have saved this particular variable name. Okay, I've saved this particular variable name to this value to this particular variable name. So for me to be able to retrieve this value in the future, what I need to do is to call those variable names. So I need to call those variable names before they can come out. Okay. So if I want to do anything, I have to call those variable names and then they can do. So one way to do that is to use the print function in Excel. In Python. The print function in Python prints out the value inside a particular variable or whatever that you want to see. So I'll use the word print, okay, and I'll open parentheses and I want to print x, okay. So when I run it, it should give me the value that x is holding. So as soon as I run it, it gives me the value that x is holding, okay. So let me just print that of y2. So y, and if I run it, you see that it will print the two of them together. Now, another way that you can get this value is you can just call the variable name like this, and then once you call the variable name and run it, it should give you the answer. So that is variable. And then variables can be used, you can use it to save even string and so many other things, okay. For example, let me say that I want to save let's say a is equal to, and then I want to create a sentence where this particular variable will hold that particular sentence for me, so that in the future I can reference it. So in that case, because I want to create a string value, which is a long list or maybe a sentence, I'll put the sentence in quotes, okay. So this is my first time. So let me say this is my first time to Python programming. Okay. So once I close the code. When I run it, nothing happens. But at any point in time, I can call this particular value out. Okay. I can call it out. I can use the word print. So print a. So print a, and when I run it, then it should bring me what is inside or what that particular variable is holding, which is this is my first time to Python programming. So it will actually print out that particular value for me. Okay. Now we see that the variables, if we are using the variables, there are certain rules that you have to follow. Okay. You don't have to, when you are using variables, when you are trying to use variables to name variables, okay, give names of variables, there are certain rules that you need to follow. Okay. The first one is that we say that the variable name can contain letters, numbers, and underscores. Okay. They can contain them. So let me put that let's put that one in markdown. Okay. So you can say that variable names can be, so they can be letters, they can be numbers, they can be underscores. Okay. So underscores. So that is one. Let me use it as points. The next one is like variable names must start with a letter or underscore. Okay. They must start with letter or underscore. Okay. So they must start with or underscore. This means that you cannot start a variable names with what do you call it? A number. Okay. You cannot start a variable name with a number. You cannot start a variable name with what do you call it? There are certain variables, there are certain letters, keywords. Let me put it out, keywords, they are reserved. You can't use them. For example, you can't use a keyword like if. because it's a reserved keyword in Python. You can use a keyword in Python. You can use else, you can use while, and so forth. So there are so many other things that you have to use. And then variable names are case sensitive. Okay, so variable names are case sensitive. Okay, so they are case sensitive. So it means that you cannot just get up and start to use variable names anyhow. For example, if I say maybe I'm using a number. Okay, let me say, let me just use 5 to try to say something. It should here, let's say 5, and then I want to assign it to me. It will automatically give me an error. Okay, it will give me an error because the 5 cannot be used to save use as a variable name. So that is one thing you should note. So when you are giving a variable name, you should take note of that. One of the best way that you can always name variables that I always want everyone to do is we call something camel case. Okay, we call something camel type. Now the integer data type is a whole number, okay, without a decimal point. So when you talk about the integer, just like in mathematics, the integer that we know. So integer is just a whole number without any particular decimal point, without any decimal point. So that is the integer. So for example, when we have all the data types that we have x and y, okay, if we want to want to know the type, it should tell us that that is an integer. And one way that we know a particular data type is when we use the type function. Okay, so for example, let me copy the whole of these ones, and let's test their type over here, down here. So when we run it, now if I want to know the type of the data type for the variable, my variable, all that I need to do is just need to type and then into brackets, then I'll type my variable, my underscore variable. Okay, so when I do this, it should tell me that this data type is of type integer. So this particular one is an integer. That is what it is. Now the second one too, if I want to know the second one, it should also tell me something else. So type underscore my name. Type underscore my name. When you run it, it should tell you that this is a string. So this is a string data type. So that is what we have two now. And then the next one, this one, because it's just like the first one, I won't test it. So the first data type that we should take note of is the integer data type. Okay, so we have the integer data type. That is what we should take note of. So maybe negative 25. So these two, because they are all integers, either negative or positive. So as you know, integer is we have either positive, or integer is having a positive and negative values. So they are all positive. Even 0 is an integer. So that is what you need. The next thing that we need to look at is the float. Okay, the float data type is a number with decimal points. So when you have a decimal point, that one become a float data type. Okay, so we have float. So we have the float. And in this case, let's say that my value, okay, my underscore value is equal to, in this time around, because it's a what do you call it, a decimal point, you can just give it 3.14. Okay, and then let's say another one, I have y equals minus 3.7. The next one is z equals 0.7. Now if I run all these things, it will run. Now if I want to know which data type is this particular one, all that I need to do is just to use the type function. So type into brackets, then the first one, my underscore value. Underscore value. If I run it, I can check for all of them at once. So let me just check the second one, type underscore, I have y. The next one, type underscore z. So when I run it, it's telling me that all of them are float. Okay, it's telling me that all of them are float. Better so you can decide to check them one by one. So when you check for this one, it's float. When we check for the second one too, this one too is float. So that is a float data type. The float data type is generally any number with a decimal value. So those are floats. Okay. Then we have the Boolean. The Boolean data type is actually the true or false type. Okay. So the Boolean is the true or false type. So if something is either we have something being true or false. Okay. So let's say that for example, one way that you can know is that, let's say I'm assigning x to equal to, let's say I'm using the word true. Okay, if I run this and I check type x, it should tell me that this is a bool function, indicating that this is a Boolean function. Okay, so now even if this is false too, you can also use it. And one way that we use the Boolean data type is that to check for two things. For example, I can say that I can use the word 5 greater than 3. Okay, if I run this, it will return a Boolean true. Yes, indeed, 5 is greater than 3. So this is true. On the other hand, if I use let's say 5 is greater than 7. Okay, if I said 5 is greater than 7 and I run it, it should tell me the other way. This is not true. 5 is never greater than 7. So that is how we use the Boolean function. Okay, that is how we use the Boolean. So at any point in time, the Boolean data type is those ones that with the true or false, the true or false. Okay, so that is about the Boolean. Now there is also another way that the next thing that we want to look at is the string. Okay, as I talked about the string earlier on, the string data type is a sequence of characters. Okay, a sequence of characters. In Python, strings are just represented by the character, the str, that is the string character data type. Okay, so I can write a long sentence and then that becomes my string, or I can just write only one and then that will give me the string. For example, a name, if I put something in quotes, that should tell me that is a particular, that one is the string. So for example, x equals, then I'll put into bracket hello. So when I use the word hello, then I close it. So let me just close it. If I run this and then I check the type of this one, it should tell me that this is string. So this should be string. When I run it, I'll get the str showing that this data type is string. Okay, because the value inside the variable name x is holding a string. Now one thing you should note is that even though over here we have saved x for something, but as soon as we got here and we use x again, the new one would appear. What Python does is that it's as soon as you resave the name or you give that particular name to a different variable, it will override the first one. Okay, so you can see from the start that over here we started using x. Somewhere we use the x value over here. Okay, but along the line, as soon as we use x again, it overrides the first one. So we use x over here, and now it will override the old one. When we use x over here again, it will still override all those ones. Okay, so this becomes the current value that the x is holding. So anytime that you repeat a particular variable name, it will override the old one. So you should take note of that when you are using your variables name so that you don't repeat them. Okay. Now this is a short string. One another string that we can use is that we can actually put write a long sentence with one string. Okay, and that one we call it multi-line. Okay, multi-line. For example, if I decide to write a long statement, okay, let me just copy any of the statements over here. If I decide to write this particular statement, so let me copy the whole of this. Okay, now if I decide to write any of those statements, okay, and assign it to a particular value. Now one way that I can use is that I'll put it in string like this, and then I can break it down. Now if I just use only one line like this, it's too long. It's too long for me. Okay, it's too long for me. It's giving me error. Yes, it will give me error. I will explain the reason why I'm getting this error in a few minutes. Okay, so when we use this particular one, it's giving us an error. It's too long. Okay, let's just cut some of them away. Okay, I will explain the reason why we get an error a bit. So now if I run this, you see it's long. It's just only one sentence. Now if I want to make sure that I have it in multiple lines, okay, one way that I can do is that I can either use the single quote 3 times. So 1, 2, 3. And now anything that I will type, if I move on, anything I type, any line, all of them are in the string. So for me to come out of that, I have to put another 3 quotes there, so that now anything I type is no more a string. Okay, so let's just paste everything once again. Let's just go to the top. I want to copy the whole of this, and then I'll now go and put it there because I want to write a multi-string. I want to write a multi-line. So I'll use 1, 2, 3, and then I'll paste it. Then I'll go down, and then 1, 2, 3. When I run it, this is what will appear. This is how it will appear. It's appearing as that it's giving us, you have the forward slash n, and then as soon as it's finished, the forward slash n. Those are sequence lines. If I don't want that to appear, I have to give an assignment. Maybe I have to assign. Okay, so let's say I will assign as a equal to. Okay, so when I run it, I shouldn't see anything. But as soon as I come here and I print out the R, if you see that this is how it will appear. The end, the backslash n is a sequence line showing that, okay, this is just jumping. Okay, it's jumping like one particular line to another. So that is what is happening over here. Now if I use the print function, the answer becomes different. So that is the difference between the next data type that we want to look at is the set. Okay, the set data type. So just the normal set. And with the set data type, you say that it's an unordered collection of unique items. The set is always unique. Okay, the set is always unique. It's a unique data type. So if, for example, a particular set, I have the repetition of so many other numbers, okay, if I convert that particular list to a set, it will change all of them to be unique. Okay, so it has to contain a unique values. So it contains a unique value, and the way we represent all of them, but this time around we use the curly brackets rather. So that is how we use the sets. Okay, so just changing the list to a set. Okay, so when I run it and then I type, I check the type of X. Now it's have to give me that this is a set. So it have to tell me that yes, this is no more a list or tuple, but this is a set. Now, as I explained earlier on, you can see that we are using x, x, x. At any point in time, x gets updated to a new thing because we are assigning a new value to x. So over here, x is being referenced as list. But when x comes here, it's now become a tuple. And when it comes, it now become a set. For me to know that, for me to use x as a list again, or to reference this list again, I have to rerun this particular cell. And when I rerun that, it means that I've updated the x back to this particular value. So that is what you need to know. So if you want to use only a repeated values throughout, a variable throughout, you would always end up getting the latest one, whereas the former one will get over, it's like it will override the former one. Okay. Now let's also look at a dictionary. Okay, let's look at a dictionary. Okay, so a dictionary, on the other hand, is also an ordered collection of key value pairs. Okay, with this one, we have a key value pairs. It's like, okay, I want to create maybe a list of maybe the names of people and then their ages. Okay, I want to create a particular something that will reference, we have the name of a person, the age of the person, and then the city of the person. One of the way that we can use is using the dictionary. Okay, so we have the dictionary, and the dictionary here, we also use the curly brackets just like the way we use the set. However, with this one, you have to pass a key, okay, and a value. So the dictionary has two things that you have to always put in mind. We have the key and then the value. So we have key value pairs, where the key reference to a particular the headings or whatever you need, and then the value represents what you are storing inside. So let's just create one. So let's dictionary. So for example, let me create a new one. Let's say that the first one I'm using, the first one I want to use maybe some names. Okay, so let me just reference this one as x. So I say x equals, then I'll open my curly brackets, and now the first thing I need to pass is the key. The first thing I need to put on is the key. So let's say that I want the key is a name. Okay, so I'll also put that one in quotes. So name, then I close the quotes. As soon as I close the quotes, I have to bring in colon. So the colon signifies that yes, this is the key. Okay, the colon over here signifies that this is a key. And now I'll now type the value. The value is, let's say, a name. So let me type John. Once I'm done with that, I have to give a comma. In case I want to type more. The next one is maybe the age. Okay, so maybe age, then I'll put colon again. So I can now type the age of the person. So 26, then comma. Then I will now come to, maybe I want to type the name of the city of the person. Also colon. And then I can now type the name of the city. So maybe New York. So New York. And now once I'm done with that, I close it with the curly bracket as well. Okay, so I can run it. As soon as I run this, if I check the type of what I just typed, it should tell me that this is a dictionary function. This is a dictionary. Okay, good. It should tell me that this is dictionary. That this one represents a dictionary. And one way that I can refer to all of them is by using the key. Okay, I can use the key to actually get the values inside the dictionary. Okay, so that is one way that you can actually reference to the dictionary. So let me use the print keyword. Let me print the dictionary. So as soon as I print it, I get the whole of this one. Okay, I get the whole of this one. But if I want to get only the keys, if I want to get only the keys inside over here, okay, let me see which ones, all of these, which ones are the key. I will type the name of the dictionary and then dot. Then I'll use a key. Okay, then I'll use the keys keyword, the keys. So I'll open and close the parenthesis. As soon as I run it, it should tell me those things that are the keys inside this particular one. And you can see the first one is the name, the age, the city. They are the keys. If I want to get the values over here too, I'll use x dot. Then I'll use the values. Okay. So as soon as I use the values, the x dot values, it's giving me the values name, the values as well. The value and the John, the age, and then the New York. Okay, so these are the values and these are the keys. So you can reference to them by the keys and then the values as well. And then another thing is that we can actually update the dictionary, or we can pick out a particular one. Let's assume that I want to pick out a particular the name. If I want to pick out the name, what I'll do is that the name of the dictionary, which is the X, then I'll open a square bracket, okay, and put quotes inside and now type name. So I want to get this particular one. Okay, so let me run it. As soon as I run it, I get John, because I'm referencing to only this particular key. Similarly, if I do this for the age, the city, I should get all of them one by one. And also, we can also use this method to update the list. Okay, we can use this particular method. Let's assume that I want to use this method to just change the name of John to maybe Matt. So if I do this into brackets like this and close it and assign new one, so I want to assign new one, new name. Okay, so if I do this, it's that the list has been updated. Okay, the list has been updated. So if I do print X, it should change the name of Matt for me. So it's now showing that the John has been replaced with Matt. Okay, the John has now been replaced with Matt. Inside, at first, it was John, but because of this particular method, I said that okay, this particular key, change the value of this particular key to this, and instantly it will change it from John to Matt. Okay, so we can do the same thing for all the keys inside and that. Okay, all right. So that is how we can update our list. All right. So that will end on there are so many other data types that we can talk about, but these are the common data types that we often use in our analysis or whatever we are doing. As we move on, we see the complex other data types, but the most important data types are those that I've just showed you. Okay, so let's move on. The next thing that we will be looking at will be operations. Okay, we'll be looking at operations. So operation in Python. So let's talk about the operation in Python. Now, before we talk about the operation, I just remember something. Before we talk about the operation, let's talk about how we can convert one data type to the another. Okay, how can we convert one data type to the another? We have so many data types. Can we convert it to other data type as well? How do we do that? Okay, how do we do that? So, for example, if I have a list of maybe x is equal to 7, y is equal to maybe 2.5, 5. Okay, so if I have this, and then if we check the data type for the first one, it will give us an integer. The second one will give us float. Okay, so let's just check them. So we have the first one, x, is an int. The second one is float. Okay, so let's assume that I want to change the first one to maybe float. Okay, I want to change the first one to float. Sorry, the first one, which is an int, I want to change it to float. Let's see how we can do it. So let's say this time around I want to assign a new value. So what I will do is that, because I want to change it to float, I can say float, okay, into brackets. Now instead of this particular name, the x, I'll come and put the x here, and then I'll run it. Automatically I have changed this particular data type to the x to float. So if I print z, it should now tell me that z is now taking this particular value to float. Now what I have done over here, I have not changed the value of x. If I still print x will still be integer. But right now what I'm doing over here is that I'm assigning a new value to z, and what I'm telling z is that, okay, z, your value will be the float of x. So that is what I'm trying to do. So that is one way you can literally just do your conversion without saving it in any other one, so that it will just override. If I want to override the x to become a float, all that I will do is that I won't use the z over here. I'll rather use the x, so that when I run it, the x over here will be overwritten. So I can now print my x and I'll get my float. So right now the variable x is now having the value float, which is a float value. Okay, it's having a value 7.0, no more 7, which is now a float value. So that is one way that we can change the data type. Okay, we can convert the data type. Similarly, I can convert this particular y to a string data type. So let's assume that I want to convert the y, which is a float, to a string value. All that I will do is that, let me assign it to the same value. So I'll say equal to, then I'll use the string, which is str, and then I'll type in the y. So now y is now what do you call a string. If I check the type of y, it should tell me that this is a string value. Good. So this is a string value. So this is how we convert from one data type to the other. Okay. Literally, you can convert any data type to a different data type as you want when you are doing your analysis. Okay. So that is how we do a conversion, data type conversion. Okay. So now let's move on to, what do you call it, operations in Python. Okay, so we say that the operations in Python are just symbols or keywords that are used to perform mathematical operations on variables and value. Okay, so we can use the operations just calculations on so many, either variable or a value. So both of them all work together. Okay, so that is what we look at. The first thing that we will look at is the arithmetic operations, which is the addition and subtractions, division, multiplications, and others. So those are the first operation that we will look at. Then we also look at some of the comparison operations. Okay, so okay, let's talk about mathematics operation. So if I have a value saving y, okay, a variable y is saving a value, let's say 33. Then x is also saving a value, let's say 51. Okay, then we have z also saving a value, maybe 5. Okay, now if we want to do addition, we just need to add. Okay, we just need to add that value. So maybe I'll do print, and then I'll put into brackets So let me say I want to add x and y. So x plus y. Okay, now I'm referring to the variable names, the names of the variables, not the values inside that particular variable. So that when I do this particular addition, what it will do is that it will go and pick the value inside that particular variable and add it to the value inside the second variable. So when I do this and I add, it means that it's saying that pick the value of x and then add it to the value of y. So that is how we do operations, the mathematical operations, that's additions. Similarly, we can do multiplication, division, subtractions, and all others. So let's just say that the next one I want to print, on the next I want to print maybe x minus y. The other line I also want to print maybe x, so y multiplied by z. So the next one I want to print division. So let's say we have print, and then we have y divided by, let me just do by 3. Okay, so let's do all the printing. So you can see it will print everything all together for me. So the first one is addition, the first one is subtraction, the next one is multiplication, and the last one is divisions. The reason why the division automatically returned floats for me, okay, which becomes 11.0. So that is how we do the mathematical operation in what do you call it, in Python. Now there are other operations that we will also look at. It's not only this one that we can add. We can also do for example, if I want to maybe 2 raised to the power a particular number, how do I do it? Okay, and one of the operations we use is that if, for example, I want to type 2 to the power 4, 2 to the power 4, let's assign it to a value. Let me say that the value here is a is equal to 2. For me to say that 2 to the power 4, I have to use 2 stars. As soon as I put 2 stars and put the 4 here, it's saying that this particular one means that 2 to the power 4, which is 2 times 2 times 2 times 2, 4 times. So that is that. If I run it and then I now print a, if I print a, it will give me that this is 16. Okay, that is when you, let's go to the whiteboard. That is, we are saying that this is actually 2 to the power 4, which is equal to 2 times 2 times 2 times 2. Okay, so that is how it's doing the computations. So this time this will give us 4 times this will give us 8. 8 times 2 will give us 16. So that is how it's doing the calculation. So when we say that 2 star star 4, that is what we try to mean over there. Okay, all right. Now let's talk about, I want us to talk about the comparison operation. Okay, comparison operators. So when you look at the comparison operators, now the comparison operators are just used to compare 2 values, okay, or variables, and return a boolean functions, either it is true or false. Okay, so the comparison operators are just used for, they are, the comparison operators are just those functions. We have the less than, the greater than, the not equal to, greater than or equal to, less than or equal to. So those are the comparison operators. So for example, the values that we have over here, okay, if I decide to say that, okay, so print, if I say print, then I say y greater than x, it will return a boolean function, which is false. Okay, it's saying that yes, indeed, 33 is not greater than 51. So this cannot be true. So it's saying that it is false. Okay, so that is the first comparison operator. And then the next one is the less than one. So let's just print the same thing, and now let's use the less than. So y is less than x. And let's see, this time around it should give us true because the 51 is actually greater than 53. So 33 is less than 51. So that is the comparison operators. The next comparison operator is the, what do you call it? The equal operator. Okay. In Python, anytime that we use the equal to, if I say that, if I use the equal to 2 equal to 3, this one is, this particular equal to is what we call the assignment operator. Okay, we are doing assignments, so that is the assignment operator. So if you want to use comparison, whether to compare this is equal to this, we use the 2 equal sign. So in this case, we say that 2 equals 3. This one, we are trying to compare the two of them to see if they are equal, and it should return a Boolean function whether it is true or false. So that is the equal to operator. That is how we do the equal comparison. You compare two things. So for example, if I say print x equals y, it should tell me that this is false because it is not true. Okay. However, if I have a variable, values like, let's say I have t equal to 5, and then I said m is also equal to 5. If I use the comparison operator, the equal, it should tell me that this is true. Okay, so t equals m. So when I run this, it should tell me that this is true. And indeed, 5 equals 5. So that is the equals operator. Okay. Now another operator is the not equal to. Okay, just as we learned we saw in the SQL, the not equal to operator is being represented by exclamation marks before the equal to. So if I say that 2 is not equal to 3, it should return that, it should tell me that this is true, and it will also return a Boolean function because indeed they are not equal. Okay, so let's see. So if we have, what do you call it? We say that print y equals or not equal to. Okay, y not equal to x. This should say true because the y over here is 33. It can never be equal to 51. So that is the how we use the, what we call it, the not equal to operator. Okay. That on the other hand, the greater than and less than operator also just work in the same manner. So if I say that x greater than or equal to, so greater than or equal to, if it is less than or equal to, you type the less than sign before the equal to. So it also work like that. So greater than or equal to y, okay, it should tell me that it's true, and it's true. X is greater than. Okay, so it's two conditions. It's either is greater than or equal to, but x is, once the first condition is correct, it gives us that yes, it is true. So we have our x to be equal, greater than the y. So that is that, and then the opposite of the less than or equal to will return the false. So with the comparison operators, they return a Boolean functions anytime we are trying to compare two things. It's either we want to compare to see whether they are true or not. And it's not always that we use it for a Boolean function, but we can also use it to compare so many other codes. Okay, so that is how it is. Now, I want to mention some of this. On the operations, we can also apply the operations to even a string variable. Okay, so let's assume that I type a variable name k. Okay, so let's say I type a variable name over here, k equal to, then I said math. Okay, so if I run this and then I now come back to say that print k, and I want to multiply k by, let's say, 4. So if I do this, what is going to happen is that it's actually going to print Matthew 4 times for me. Okay, so you can see that it's now Matthew for up to 4 times. That is what is happening. So with all the operators, you can actually apply them to a string function as well. And when it comes to the addition, okay, in additions, we call it, we are trying to concatenate two things. So for example, if I have a string, maybe the next string is M equals, let's say, John. Okay, John. If I run this, and now I want to print, so this time around, I want to print K plus M. So let's see what happens. So it print the two together. Okay, it's actually joined the two together. But one thing you need to also note over here is that you cannot print out together when you have a string and what do you call it, an integer. Okay, when they are of different data type, you cannot add them. So this particular one is what is something like kind of concatenation. You are trying to join two things together, and you cannot join an integer and a string together. So that is what you need to take note of. Okay, so that is about the operations. Okay, we have that is about the operations. I want us to look at those are the mathematics operations and the comparison operators. So let's look at the logical operators. We also have the logical operators. With the logical operators, what we do is that in this time around, we are saying that we are used to combine two or more Boolean expressions and return a Boolean value based on the result of the operations. Okay, so we use it to just return Boolean value based on the result of the logical operations. So for example, if I have two things, okay, if I have two things, it's either I will say that, okay, for example, those values that I have, y x is greater than a particular number and y is greater than a particular number. And with the logical operators, that is the and the or, the two of them work in such that with the and functions, both sides must be true. Both sides must be true. Okay, but with the or operator, just one have to be true. The other doesn't matter. So once one is true, it doesn't really matter. So let's look at them. So we still have our x and y as these values. Okay, these are x and y. So let's just see that. Let's print the first one. Let's see that we say print, okay, into brackets. Then I'll say that print x is greater than. So I'm saying x is greater than 10. Okay, and then I'll use the AND operator, and so I'll use the AND operator. Y, okay, y is less than, let's say y is less than 10. So let's see what happens. It will tell me that it's false. Okay, both of them are all not true. However, let me just update this and make one of them true. The value of y is 33. The value of y is 33. So let me say that here y is not less than this value. So let me just increase this one to 100, showing that indeed y is less than 100. But x over here too, we know x is greater than 51. Okay, for this particular value, the x is greater than, the x is 51 and is greater than 10. So let's see, it will return true. Okay, now let's change one of them. We know that for sure for y part is true. So let's change this particular one and say that y is greater than also 100, and let's see what happens. It will now go back to false because one of the condition is not true. Okay, so this particular operator, the AND operator, where it said that both sides of the statements must be true. Okay, on the other hand, if I copy the same thing and then I run it for all, it will tell me that it is true because the or operator work is said that it needs only one of the arguments to be true, one of the statements to be true. So once that the first one is not correct, but the second one is correct, it will return true. So that is how the or operator also work. Okay, the logical operator, the and or, that is how they work. We also have the not operator. For the not operator, it also return a Boolean value. And with that case, for example, I can decide to say that, okay, this one, not, okay, not. As soon as I put not over there, so let me copy the whole of these things. And for me to use the not, I have to put the whole of these things into another bracket again. So I'll say that print, and then I'll put the not here. Okay. So as soon as I run it, it's returned true. So what I'm trying to say is that the whole of this is not true. So I'm overriding the whole of these things, and I'm saying that print this one not. If these two, all the conditions over here are true, it will return false. So that is how the not operator also works. Okay. So these are the logic operators that we have. Okay. The next is the assignment operator. The assignment operator, that I've already said earlier on, we have the equal to. Okay. So just as how we have been using the single equal to is what we are trying to do as we are trying to operate them. And it's not the only assignment operators. Okay, we have so many other assignment operators. So let me quickly just list some of them. Okay. So for example, the first assignment operator is that we have the equal to assignment operator. So if I say that the equal to assignment operator, this is how it works. X equal to 5. So I'm assigning 5 to X. Okay. The next one is we have either the equal to plus or equal to. So it's kind of, we are trying to do addition. Okay, we are doing addition. So if I say that X plus equals 5, okay, what I'm trying to do over here is that I'm picking the value of X, okay, and I'm adding 5 to it. So what literally this means that X equal to X plus 5. So this whole thing is what I'm putting together again. So what I'm saying is that my X is equal to X plus 5. Okay, and if it is X minus equal to 5, then it means that X equal to X minus 5. Okay, so that is what I'm trying to do over here. So these are also another assignment operators that we also have. Okay, these are some of the assignment operators, and we use them as we are working with a lot of data or so many other things. Okay. Another thing that we want to look at under the operators is we have the bitwise operators. With the bitwise operators, they are used to perform bitwise operations on binary numbers. Okay, so just as we have those numbers, okay, we have the bitwise end. For example, if I write something like this, okay, maybe I want to print, and then now I want to print the X, so I'll put this operator, the end operator, this one Y. Okay, so if I run it, it will give me a value. Okay, and this one is saying that it's actually telling me kind of a bitwise operations. Okay, it's the other way of the bitwise of, let's say, this one. So you have the bitwise end. Okay, so this is what is represented, and it's the same for all others. That is we have that of the or is a straight line, and then we also have the what do you call it, that the raised power. Okay, so it's kind of, we have something like, if you have a 3, and then we use this particular symbol 2. Okay, now when you run this particular thing, this is what you are getting. Okay, So it's kind of, we are trying to, the 2 is going out, when 2 is going into x, the 3, and then we are getting that of the remainder. Okay, so that is how this one also is working or giving us. Okay. The last operator that we want to look at is the membership operator. Okay, we want to look at the membership operator. With the membership operator, it works like we are having two things together. Membership operators, they are used to test whether a value or variable is a member of a sequence of collections. So, for example, if I have a list, if I have a list of numbers, a list of values, or a list of marks, for me to know whether a particular list value belongs to the list, we use the membership to check, the membership operators to check. Okay, and one of those is the in, not in operator, the two of them. So for example, if I have a list like this, maybe the name of the list is, so new, let me say new list. New list is equal to, okay, new list is equal to 1, 3, just some rounded values. Okay, then I close it. Now, if I want to check, for example, I want to check if 2 is a member of this particular list. If I want to check whether 2 is a member of this particular list, I'll use the print, then into brackets, I'll say that 2 in, okay, 2 in new list. 2 in new list. When I run it, it should tell me whether it's true or false. And if you look at the new list, 2 is not part of the new list. So indeed, it was false. Okay, 2 is not part of the new list. So once that 2 is not part, it will return false. But if it were to be part, it should give me true. So for example, let me check if 3 is part of the new list. Okay, so 3 in new list. So once I print it, it's giving me true, meaning that yes, 3 is part of the new list. The next operator is the not in. Okay, the not in. So for example, the first statement over here that I use, I could have used the not in operator and it should give me that it is true. Because 2 is not in, so I'll say not, so I'll use the not in operator. Not in the new list, and it should return true because 2 is not part of this particular new list. Okay, so these two are the membership operators that we commonly use. Okay, you can use it to check for so many other things that we know. Okay, all right. I can also use it to check for a string. So let me demonstrate that one a bit, and then we'll move on. So we have maybe I have a list, a string. Okay, let me just type a new string. Okay, I have a new string like maybe new string. So new string is equal to, so I say new string is equal to, into brackets, I say I love chocolates. Okay, so chocolate, so I love chocolate ice cream. So let me use the word I like chocolate ice cream. So once I said I love chocolate ice cream, I should run it. Now I can check whether the lab is in this particular one or not. Okay, or there are words that are not in or not. So I can say that print. Okay, or let me just forget about the print. Now let me just use the quote love. Okay, so love in, okay, love in the whole of this string. Then I'll copy the whole of this, or love in new string. Good. So as soon as I type that, it's saying that it is true because love is found in this particular way. Okay. So if I use another one, let's say I use another one. Okay, let's say I use calm. So let's say calm in new string. So this should give me false because come is not here. Okay, but if I say that come not end, okay, so come not end, then new string, this one should return that it is true because it's not passed. Okay, now it should tell me that it is not passed. Yes, true, because come is not end the new string. So that is how you can also use the membership operator. We can use it on string value as well, not only on integer or float values, but we can also use it on the string value as well. Okay. Okay, now we want to look at conditional statements and loops. Okay, we want to look at some conditional statements where we have the for loops and then the while loops as well. So the first conditional statement that we want to look at, okay, we want to look at the if statement. Okay, so but we say that the conditional statements are such that they allow you to make like your program to make decision based on certain conditions. Okay, so for example, you have a lot of conditions and then you program in such a way that, hey, go here, if this one is true, then do this for me. If this one is not true, do this for me. So it's like when something is true, it should do something. When something is false, it also do something. So that is how the conditional statements work. And the first conditional statement that we want to look at is the if statement. Okay, we want to look at the if statement. Then we will look at, so let's just look at it long. The if else statement. Okay, so the first statement that we want to look at is the if statement. And the if statements work in such that when you have a particular thing, for example, you should give a condition, and if that particular condition is true, then it should return something. So let me just draw a flow chart for us to represent something over here. So this is how it works. For example, the if else statement is a whole statement on its own. So we have it this way that, for example, if I have let's say that it's starting from here, okay, then I'll give my condition. So if the if condition is here, okay, the if condition is here, so I'll say that, okay, if this particular condition I'm giving over here, it is true, if this is true, so if this is true, then come and execute my statement. So if this is true, then come and execute my statement and give me an output. Okay, so give me an output. So when this is true, come and give me an output over here. But if this condition that I'm giving over here, if it is not true, then move to this area. Okay, then move here. Then if so, it means that if false, if it is false, come here. And now come and check the next condition. So come and check the next condition for me. And this particular conditions becomes the if else. Okay, if else. So if this is not true, if the first condition is not true, go to the false area. So if this is not true, then if else. Okay, so the if else. But when we are writing it over here, when we are writing it, we write it this way. We put all of them together, so it now becomes else if. Okay, so else if condition. So you now have the else if condition, and if this one is true, come and execute the condition I've specified over here, or the statement. So come and execute this particular statement for me. Once that you have finished executing this particular statement, come out. But if this is false, okay, if this particular statement that I have specified here, this one too is false, then come to this particular area. So we have another false statement. Come to this particular statement. And now the last one, else. This is where the else work. So now come and execute this one for me. Okay. So once that you are done executing this particular statement, come out from the loop and give me a result. So give me a result. So that is how this works. So this is how the if statement work. Okay. So it's just showing that if a particular statement is not true, if a particular thing is not true, for example, the first condition, if the first condition is true, then just move and execute my statement for me and give me an output. But if the first statement is wrong, then go to this area and go and execute the else if statement for me. If you come here and then else if statement 2 is true, if the else if statement is now true, then execute my statement and come out. But if the else if statement is also false, then come to the else statement and then come and execute and give me a result. So this is how the if else statement, all of them work together. Okay, so let's just go to our code area and then just look at some of them. So for example, let's look at them a bit by bit, then we can combine all of them together. Okay, so the first one is that I want to say that my age is equal to, okay, my age is equal to, let's say, 22. Okay, now I want to use the if statement. Okay, so the first, this one is just a simple if statement. So I'll say if. So once I say if, I'll type my age. If age, so I'll say greater than or equal to 18. Okay. So if it's greater than or equal to 18, then I'll put colon. So as soon as I put colon, I click enter. It just indents it. Okay. It will give the indentation. So now print, then I'll say that. So I'll open the parentheses and say that I'll use you are not qualified. So you are not qualified, and then I'll close it. So once I run it, because the age is not greater or equal to this particular one, it says that you are not qualified. So that is a simple way that we can use the if statement. Okay, that is a simple if statement. The next that we would also look at is that the else also statement. Okay, so this one now we want to progress further. The same thing. Let's just copy the same code. Okay, let me just type it. So age equals to 22. So now I say if, I'm now coming to use if age is less than or is greater than or equal to 18. Okay, then I'll say that print. So I'll say that print so I will say that, okay, let's assume that we are talking about voting. So you can vote. So you can vote. Then I will come out and then use another one. So this time around, I will push it backward and say that, say, else if, okay, else if age so equals maybe 17. So I'll now say that print so this time around I want to use, since you are not 18 years, you can vote next year. Okay, so If I want to continue, okay, if I want to continue, then it means I have to use the else statement. Okay, so else, okay, now the else over here, I won't give any condition. I won't give any particular condition to it. I'll just write the else and then I'll come and write print. Okay, so print, then you see that. So this one, this time around, I want to say that you are too old. Okay, so now this is what we have. And what you are trying to do over here is that you are saying that, okay, go and check the age. If the age is greater or equal to 18, print out this for me that you can vote. But if this condition is not satisfied, then it will come here. Else if, okay, else if the age is equal to 17, then print out that, okay, you can vote next year. Then, but if this condition 2 is not satisfied, then come here and come and print, you are too old. So it means that if all these conditions are not satisfied, then this one will come and print. Now let's run it and see. So since the first one, as soon as the first condition is true, it's jump out of the loop. It won't continue again. Okay, just as I say, once the first condition is true, it gives out the outcome. So the first condition is true. Indeed, age is greater or equal to 18, so you can vote. Okay, now let's change the age to, let's say that the age is now 16. Okay, and let's see. When we run it, it's jump. Okay, it will jump and then now come. The first condition is not true, so it will come to the second condition. The second condition, you are giving equal to, so it's supposed to be 18 exactly. Since it's not 18 exactly, it will not run that one. It will move to, it means that that statement is false. Then it will now come to the last statement and now come and print, you are too old. Even though this particular one is not, it's not something that we can say that it is old, but that is what is actually going to show us. Okay, that is what it's going to show us. So that is how we use the if else statement. Okay. The next one we want to take another example. Let's just take another example and then let's see how it works. This time around, let's print a lot of things together. So let's say that we say this time we say if, okay, so we want to pick some numbers and see how they will work. Okay, let's pick some numbers. So we say that if maybe 30 is greater than, so let me just use 30 is greater than 23. Okay, if 30 is greater than 23, then come and do this printing for me. So print, you can work. You can work. Okay, then I'll use the else statement. Okay, so once that you click OK, it will automatically be beneath, but you just have to press your backspace so that it will move back again. Then else, I want to just use only the two of them. Okay, then else print. Okay, now you can't work. Let me just print that the opposite. You can't. So you cannot work. So once I run it, it checks the first condition. If 30 is greater than 23, print you can work. Okay, so because 30 is greater than 23 indeed, it's showing that you can work. But if you change this particular value to, let's say, 33, it should jump to the next one. You cannot work. Okay, so 30 is not greater than, so it's now jumped to. So that is how we use the if else statement, all of them together. Similarly, we want to look at the loop. Okay, when we use the with the loops, we have two types of loops. We have the for loops and then the while loop. Okay, so we say that the loop is just used to repeat a block of code. So when we have a block of code, we use the loop to repeat them, okay, multiple times. And there are two types. We have that is the for loop and then the while loop. So let's look at the while loop. The while loop, or sorry, the for loop. Let's look at the for loop first. The for loop is used to iterate over a sequence. Okay, so that is what you use when you use the for loop. It will iterate over a particular sequence till it gets to the end. So for example, let's say that I have maybe I'm trying to say, so let me just comment this one as for loop. So with a for loop, let's say I have maybe fruits. Okay, so I have fruits is equal to a list, and now let me create a list, and I say that the first one is I have orange, then I have banana, then I have something like so you have orange, banana, apple. Okay, so you have this, and then I'll close it. Now I can use the for loop for. Okay, so now I can say for fruits. This time I just type for fruit in fruits. Okay, for a particular fruit in fruits, that is the name of the list. In fruits, then I'll put these things, and I'll say that print. So print fruits. So print the fruits out for me. Okay, and when I run this, it should print all of them one by one. Okay, now it has even combined all of them together for me. The reason why it has combined them is that I didn't separate this either with any comma. So this should work good. So it's what is happening here is that the fruit here, we say that fruit in fruit. So the word this fruit over here will now move throughout this particular list. It will go throughout the list. So it will go through this. If it sees the first one, it print it out. Then it will start again, and then come out. Okay, it has identified another fruit. Then it will come out and print it out. So that is how it prints it one by one like that. So that is how the for loop work. Okay, that is how the for loop work. Let's look at another example. So let's say we have a group of integers. So let's say we have a group of integers. Then we have int. So let me use the word integers is equal to. Then I'll create a list of the 1, 2, 3, 4, 5. Let's say up to 9. Okay. So let me run this and go to the next step. And then I'll now see that 4. So I'll use 4 for number. Okay. For number in integers. You have int. For number in integers, colon, print number. So now print number out for me. So you see, it's take it one by one. It begins, it will go. The number will iterate throughout the list of integers. Wherever it sees the first one, it prints it out. Then it will go back again and go and iterate, go and check out like that, and be printing up line after line. So that is how the integer, the for loop also works. It iterates through a particular given list and then print out all those that we have. Okay. Then we have the while loop. Okay. With the while loop, you see that the while loop is used to execute a block of code repeatedly. Okay. So with that one, we are trying to repeat something for several times. Okay. So it repeats something. So that is how the while loop also works. Okay. And one thing you should notice that we can print, we can create another loop inside another loop, and that one we call it the nested loop. Okay, so you have the nested for loop or the nested while loop. When we start doing our data cleaning and stuff, we look at some of these loops. Okay, so we have the next one will be the while loop. with the while loop, we say that, so let's just look at some of them, how we can create example. So you have while loop, then the while loop we have, for example, let me just assign I. Okay, over here, let me just say I is equal to 0, and then I'll create a, so I'll say while number, so while a particular number is less than, okay, it's less than I, so it's less than 4, okay, 5, it's less than 5, colon, I will say that print the number for me. Okay, so print the number. So once you are done printing the number, I will want to increase the number by a particular, so I'll say number is equal to number plus 3. Okay, so this way. Now this particular way is where we have one of the assignment operators. So let's run this and see what will happen. It didn't give us any answer. So you say that I is equal to, oh, okay, sorry. We are using I and then number, which they are not the same. So let me just clean all this and make it I. So you have I. So I is equal to I plus I. So this way, good. So what happened over here is that, first of all, we have assigned 0 to I, okay? We have assigned 0 to I. So while I is less than 5, print I. So because the first one, I is less than 5, it will now print I, which is now 0. Now it's move on again. Well, after you finish printing that one, increase I by 3 and then print it out. So it will increase I by 3, which is I is equal to I plus 3. And then that value is now become the new value for I. So that is, it will print it out. Now it will go back and check again. Is I still less than 5? Yes. Okay. So it keep on like that till I becomes greater than 5. As soon as I becomes greater than 5, it cannot print out again. Okay. So it will only be printing out when I is less than 5. Because over here, when it add another 5, that particular, when it add another 3, it will become greater than 5. So it won't work. That is why it prints out only 3. Okay. So let's, for example, increase this particular one by, let's say that it should add only 1, and let's run it. So you see that it will now move more. So what is happening is that it's doing it this way. The first value of I is equal to 0. So when I is less than, okay, when I is less than 5, it will now print out the value of I, which is I is now equal to 0. Okay, and then we say that, okay, when you finish doing this, now add plus 1 to I. So it will add plus 1 to I, and then the new value for I will now become 1. So I is no more 0. The new value is now 1. So it will go back and go and check, is I is equal to 1. Is 1 less than 5? Yes, once 1 is less than 5, add 1. So it will become plus 1. So the new value for I is now equal to 2. Okay, so once the I is equal to 2, it will go back to go and check again. So is I still less than 5? Yes, when I is less than 5 plus 1. So it will add plus 1 again, the I is now equal to 3. It will go and check again. Yes, it is less than, so plus 1. So I is now equal to 4. It will go and check again. Is I less than 5? I is less than, but when it add plus 1, it will be greater, it will be equal to 5, which is equal to 5, not less than 5. So because it's now equal to it doesn't satisfy this particular condition, so it cut off from the loop and then stop working. So that is what is happening over here. So that is how the while loop work. Okay, so that is how the while loop work. Now another thing you need to note is that we can actually combine the while and then the if loop all together. Okay, so let's just give it a try. Let's just combine the two together and see what we can get. So for example, I'm trying to, let me just say, use the I again. I is equal to 0, and then I'll use the while. So I'll now say that while I is less than 5, while I is less than 5, then I'll say print I. Okay, print I for me. So when you are done printing I will now come and check a new condition. If I is equal to, if I is equal to 3, okay, if I is equal to 3, then now come here and break. So I'll talk about a break a bit. Okay, so break, and then I'll say that I is equal to, okay, I is equal to I plus 1. Okay, like this one. And then I will conclude with else statement. I will say that else print, so else print something like this for me. So let me say no. Okay, just print no for me like this. So let me run it. So now this is what is happening. We are getting this. So we combine the if else with the while statement. So what is happening is that the first of all is checking, is I less than 5? If I is less than 5, we print it out. Okay. Now since when it prints it out, it will go and check if I is equal to 3, then break, don't run again. That is what the break is doing. The break function is actually cutting short. If the function is no more, if it goes to a particular time, just break for me. So it will continue like that until it gets to the break. When I is now equals 3, it will break. If I is not equal to 3, it will iterate through the loops to the end, and then it will start all over again. So that is how we combine the two of them. Okay, the break section, the break, I'll talk about it a bit. So let's just move forward as I talk about the break. So you have the break and then the continue function. Okay, the break and the continue function, the break and the continuous sequence there. We use it to terminate loops. If we have the while loop, we call them the transfer statements. Okay, with the transfer statements, they are used to transfer the flow of control from one part of code to another. For example, if I'm running a particular code, I can use it to terminate the code at any point in time. And the first one is the break. The break statement is used to terminate a loop statement, either for or while loop statement, before its normal completions. For example, for this particular one that I have done over here, this is not the where it's supposed to end. It's supposed to end at when I is actually less than 5, which is supposed to be 4. Just like this same statement, it's supposed to end at where I is exactly less than, which is 4. That is where it's supposed to end. But we are terminating it with the break keyword. So the break is used to terminate the for or while loop even before they reach the completion. Okay, so that is what the break statement does. We are terminating the loop before it even reaches the completion. Okay, so that is it. So for example, let me use a for loop and I will break it. So let's say that I'll say that for I, and I'll use in range. So let me use the word range, in range, and I'll type something like, okay, let me give a keyword 10, and then since the for loop, I'll open it this way. Then I'll say if I equals, it's just like the same what we just did previously. 5, then break. I'll just use the break statement, and then I'll now come and say print I. Okay, and run it. Good. So this is returning. Oh, sorry. The if statement supposed to be not supposed to be 1. It's supposed to be I. So if I use if 1. Sorry. Good. Right. Yes. So it will now run up to only 4. The reason why is that the range we specify is 10. Okay. So it's supposed to be within, if I is equal to 4, I is in those particular range. So from 1 to 10, there's 0 to 10, those particular range. And now we use the if statement, and we are saying that if you continue running from 0 to, before you get to 10, at any point in time you have I is equal to 5, break, and then print out the result for me. So because it reached here and I is equal to 5, it will break. It won't even return the 5 itself. Okay, it will return those, it will break and not continue the running again. Okay, so this print will not work for that one. As soon as you get to this particular one, as soon as you get to this particular statement, the break sections will now separate the print from appearing. It will now prevent the print from appearing. So the 5 itself cannot be printed again. Okay. But if it comes 0, it's not equal to. So it will jump and come and print. The break will not have any effect. 1 is not equal to. So the break will not have effect. So it will continue like that until it appears to be like, okay, now 5 is equal to 5. Then it will break. It will continue again. So that is how the break function works. Then we have the continue function. The continue functions works in the opposite direction. Okay. So let's say that we want to use the same thing. All that we do is that we use the continue keyword. For that one, we are saying that, okay, just continue. When you get that, continue. Okay. So we say continue. So we use the continue functions. And that one, it will continue running till it gets to the end, because we are within 0 to 10. So it's supposed to run out. So the continue, it will continue. It will continue and end at the specified end time. So that is how the continue function works. Okay. So with the continue, it will continue, it will break. So that is about the transfer state, the two transfer statements. Okay, that I want to talk about. Okay. Now I want to talk about a bit about functions. So let's just deal about functions, and then we look at the other two things where we talk about computations. So we have the functions. We are the functions. How do you create? What are functions in Python? Okay. So under functions, it's just like they are specifically object-oriented programming aspect of our work. Okay. And we say the function is just a block of organized and reusable code that perform a specific task. Okay. Now functions help us a lot. Okay, because when you create a function, you can reuse it later on. You can continue to use it at any point in time. It will still be there for you to use later on. Okay, so let's just create a bit of it. And for us to create a function, we start with the keyword diff. Okay, we start with the keyword diff, so that at any point in time we can use that particular keyword. So let's say I want to create my first function. So I'll say diff. As soon as I use the keyword diff, I can now write the name of my function. So let me use the name as first function. Okay, so I'm using the name same function, and I'll open parentheses like this, and I won't put anything inside. I'll just bring my colon. So I'll now come and do the print out what I want to print. Okay, so inside I'll say my first function. So my first functions. So I can now run. Okay. So once I run it, nothing will appear. But if I want to use the functions, it's a function I've created. So I can use it later on. I can use it to work later on. So if I want to use it later on, I have to call the name of the functions. The name of the function is the first func, okay, the first function, which is like this. So the first function, as soon as I do this and I run it, it should return what is inside the function, which is my first function. Okay, so the function that we create, we use the diff function. And in fact, you can use it to create, you can create so many things out of it. For example, you can create calculator out of it where you use it to compute. Okay, so let's just create a function that we can use to compute the square of a number. Okay, let's use a function that we can use to create, let's just create a simple function where we can compute the square of a number. Instead of us typing the square root, or sorry, the square of a number, we just give it the number and it has to perform those numbers for it. So I will start with diff. I will say diff, and then I will say square. Okay, so let me use the word this one. Okay, so let me just say, okay, let me use the squared, the whole squared. Okay, so let me just open it this way, and then so inside now I will now come and do the what I want to perform, what I want to do. Okay, what do I want to do? The functions have been defined with this part, the function name like that. So you have the diff and then the function name. Now what do I want to perform? So I will say that print, and then what I want the function to perform for me. And what I want the function to perform for me is I want to specifically find the square root. Okay, so I can say that, let me put number here. So I'll say number, and then I'll give the square root. I'll do it this way, and this particular number will now become the argument. Okay, will now become the argument of the functions of what I want to return. So because of that, I'll put the number also inside this particular one. Okay, so when I run this, nothing will appear, nothing will happen. But anytime I call the function squared, it will take an argument, because I'll specify an argument as a number. Okay, a number argument over here. So now the next time I type squared, okay, it should take a particular argument, which is the number I've specified inside. And the number, as soon as I give that particular number, these calculations will be performed on the number. The number raised to the power 2 will be performed for me. So let's say, let me give a number 4. Okay, as soon as I run this, it should give me, it means that we have 4 to the power 2, and that is the answer is being returned for me. So that is how we create function. Okay, that is how we create function. Oh, so what we should take note is that the function, we have the function called and then the function output. Now over here, what you can see over here, this 16 is actually the function output. Okay, and what we see inside here, the square term, is the function call. That is how we call the functions, and the whole of this one becomes the functions body. Okay, this one, the whole of this one becomes the functions body, where what we have inside becomes the functions parameter. So whatever that we give to the functions, the function will take it and then go to the print statement and perform the assign statement that we've given to the functions, and then before returning the output. So that is how the function work. All right. So the next part that we want to look at is the computation. Okay, we want to look at how we can manipulate data with NumPy and Pandas, and also Matplotlib and Seaborn. So those are the two things that we want to look at before we end this lecture. So the first one is the NumPy. Okay, so what is the NumPy? Then we say that the NumPy is actually used for computations. Okay, That is used to manipulate data. We use it to manipulate data. Okay. So we said the first one is the NumPy. The NumPy is actually a package that stands for numerical Python. Okay, the NumPy stands for numerical Python. Okay, and we say that it is a library that provides support for multi-dimensional arrays and matrices. Okay, as well as a range of mathematical functions to perform computations. Okay, so it actually gives us it provides us with interface where we can do computations on arrays like matrices as well as other range of mathematical functions. So that is what the NumPy does. It helps us with. And then an array, we say arrays are the main data structure in NumPy. Okay, so that is what we do with the NumPy. And when we talk about the pandas, on the other hand, it's a library that helps us to do data manipulations and analysis. So basically, the pandas, it's a very good library that we need to know how to use. For example, when you are doing your data manipulations, data cleaning, you would have to use pandas a lot. So the two of them actually work hand in hand, the NumPy and then the panda. When you use them, you can be able to transform your data. So let's first of all just take a look at the NumPy, how we can use the NumPy, how we can start using them and create arrays with them before we can use. So as I said earlier, the NumPy is actually used. It helps us to work with arrays. Okay, it helps us work with arrays. And for you to begin using NumPy, the first thing that you need to do is to be able to install the library successfully. That is the first thing that you need to do. If you have not installed the library, you cannot use it. Okay, so for us to install the NumPy library, let's just try to install both of them before we can import them. And we use the pip function. Okay, so we use the pip function. So let's just start with the pip, and let's start with the exclamation mark, exclamation, the pip. Then we say that pip install NumPy. So pip install NumPy. I've already installed it. So, but if you've not installed it, it will install for you. Okay, I've already installed it, but then it will still run again, and then it's giving me that requirement already satisfied. NumPy in. So it's showing that NumPy is already installed. So if you have not installed it, that is how you have to install it, and then when you run it, it should install successful for you. Okay. The same thing if you want to install the pandas too, it follows the same procedure. Okay, that one too I've already installed it, so the requirement is already satisfied. But let me just show you. So you have the pandas. So it should also tell me that the requirement already satisfied because I've already also installed. So yes, requirement already satisfied. Okay, so that is how we install both the NumPy and the pandas. Now let's start our first data manipulations, how we can use the pandas. Now, since you have done, now once you are done installing it, okay, if that is the first time you finish installing it, you have to restart your kernel. Okay, for example, you have to come here and restart your kernel. Just click on this the circle where you to restart your kernel so that you can be able to use the NumPy and then the pandas as well. In fact, at any point in time you install any library, you need to restart your kernel. Okay, so this one, let's try to import them. When you finish installing and you restart your kernel, before you can use the NumPy, you need to import it. Okay, so we use the import function. So you see the import. So import, then I'll import NumPy. Okay, now just like the way we use SQL, the way we use the alias, we use the as for the alias. The same thing happened over here. Because I want to, so the common abbreviation we normally use for NumPy is NP. So that all the time I won't be typing the long NumPy, but I'll just be typing NP. Okay. So I'll say that import NumPy as and then NP. Okay. So that is how. And then I'll just run it. Once I run it, NumPy is now loaded. The NumPy library is now loaded. So I can do any computation I want. The first computation I want to do is to create an array. Okay. I want to create an array. So let me just name it as array is equal to, okay. Now because I want to create a particular array, I'll say that np dot, then I'll create the array. np dot array. So I'll open bracket, and then inside the bracket I want to input list. So 1, 2, 3, 4, okay, 5. Then I'll close it. Okay, now let me print out the outcome and see what will come. So print into bracket, then I will now say that I want to give it a name. Okay, I want to give the outcome a name. I can just say that print array, the array that I've created. It will print everything together. But I want a nice way to print out this. So I will say that print, and then I will say maybe NumPy array. So NumPy array is then colon. Okay. So with that, let me close it here. So what I will do when I do this, it means that my NumPy array will now have a name. Oh, okay. Perhaps you forgot comma. Yes, there's supposed to be comma here. Okay, good. So it says that the NumPy array is, then it will print out the array for me. This is just a printout statement that I'm trying to use. I'm just trying to tell it that, okay, just give it that particular name so that it will look nice for me. Okay, so that is how we print out the NumPy array. Okay, now we can create so many arrays, like for example 1D array, 2D array, and so forth and so on, where we have 2 columns. So we have maybe we have, what do you call it, there will be a 2 columns array, or 2 by 2 matrix, or whatever. So for example, if I want to create a 1D, this particular one looks like a 1D, but let me just create a 1D array. Okay, so let me say array, so 1D. So let me just put it this way, and then I will say np.array. Okay, so this is how we create the array. So I'll say np.array, then I'll open brackets, and then I'll create my first array because I want to create just only 1D. Okay, because I want to create only 1D, I'll just open only one like this, and then I can now input my array just like the first one. Okay, so basically this is so if I come out and print 1D array, so array 1D, it should print out this for me. Okay, on the other hand, if I want to print a 2D array, it means that inside this particular bracket I have to give some kind of 2 list. Okay, so let's say that array 2D, so array 2D, then I'll say equal to np. Okay, the np is very important because that is what we are using to create the array. So the NumPy functions, if I didn't specify that import NumPy as np, I just said import NumPy, then it means that instead of the np, I'll be typing the full NumPy. Okay, I have to type the full NumPy as a word. So but in shorten this, make it so easy for me. So I have this. So I have the first one, maybe 2, 3, 5, and then I'll close it, comma, and I'll create another one again. So inside I'll create another one, also maybe with the same length. So now I create, once I do this and I print, this should be a 2D array. So let me just print 2D. Good. So it should give me that this is a 2D array. So that is how we print about the 2D array and then the 1D array. So basically the NumPy helps you create a lot of arrays that you can create of. You can also create the a specific arrays with a specific dimensions. For example, I can create an array of zeros with a specific dimension, which will be maybe a 2 by 2 matrix or 3 by 3 matrix. For example, if I want to create a 2 by 3 matrix, just like this one, this is a 2 by 3 matrix. If I want to create a 2 by 3 matrix of zeros, okay, of zeros, we use the zero functions. So instead of using the array, I'll use np.zeros. Okay, so for example, let's say that, let me say 0, okay, 0 arrays. So equal to, then I'll say np.zeros. Okay, so as soon as I say np.0, now I will now give the, what do you call it, the function, like the dimension, a specific dimension. I want it to be 2 by 3. So I want it to be 2 by 3. If I run it, cannot interpret the 3. Yes, it's supposed to be, I was supposed to give it 2 square brackets, 2 brackets. Good. So once I give it 2 brackets, it's worked. So now if I print 0 arrays, it will have to give me like a zeros matrix, okay, a matrix of 2 by 3, which is all zeros. So I have 0 arrays. So when I run it, it will give me zeros throughout, okay, a 2 by 3 matrix of zeros. So that is how we create the zeros array, okay. We can also create that of ones, okay. So that one to use the ones, and we can also create identity. So let's just create the 2 of them first, and then so instead of the zeros, I'll use ones, okay. So it's just the same way. You can just say that. So instead of the 0, I'll say ones. So we have the ones array. Okay. So when I run it, if I run this and then I print out the ones array, it should give me all of ones. Similarly, I can create that of identity. And with the identity, we use the I function. We use the I. Okay. So let's see that identity. So identity array. So I will say equal to np dot I, the word I. Okay. So once I use the word I will just open one bracket. What dimension do I want? Mostly the identity matrix is a square matrix. Okay. So it's a square matrix. So it's either a 2 by 2 matrix, a 3 by 3, a 4 by 4. So if I want 4 by 4, just give it only one parameter, which will be 4. So when I run it, it should give me a 4 by 4 matrix, which is an identity. Okay. All right. So let's say identity array. So as soon as I run it, this is what is happening. And the identity matrix, one thing about the identity matrix is that only the diagonal becomes 1, 1, 1, 1, 1. The upper, the diagonal, and the lower diagonal, they all becomes 0. So you can see that the middle one throughout are ones, whilst the upper, all the upper over here are all zeros, and below are all zeros. So that is how we create an identity matrix as well. Okay. With the arrays as well, we can do some computations. Okay, we can do computations just as we did. Some basic computations can be like we are adding certain values to some arrays. So for example, let's just look at some few identity mathematics operations. So let's say we have array to be equal to np dot array, and then we want to give it like 1 2 3 4, okay, 5, and then we close it. Okay, so if we add this particular array, so let's say array sum, so array sum is equal to, then this our array will now be plus, let's say plus 5. When we run this and we print out this sum array, okay, let's print out this sum array and see the outcome. When we print out this sum array, this is what is happening, what we are getting. So the array functions over here, it's adding the 5 to each of the values inside the array. Okay, it's adding the 5 to each of them. So it takes the first one here and add plus 1 and plus 5 to it. Come to take the 2, add plus 5. Take the 3, add plus 5. Take the 5, add plus 5. And then store that as the array sum for us. Okay, so that is how we do. The same thing, we can do the multiplications, and it does it the same thing. Divisions, all of them the same thing as well. Okay. Let's look at another example where we do the other part of it, where we can do more computations. Okay, we will do, as we move on, you look at more of the computations of the array, and then we can see. Now, the thing that I want to talk about is, just as I said, we have the indexing. Okay, just as I explained earlier on, the indexing. Now with the indexing, it actually starts with just as the first element inside as 0, the second element to be 1, and so forth to the end. Okay, so it's the same thing as we do in the array as well. So when you take that is the same thing that it's look at. Okay, now let's quickly look at pandas. Okay, let's quickly look at how we can also do computation with pandas. With the pandas, we have already installed it. So if we want to use it too, we also have to import it. So now let's import pandas. So import pandas as, this time around we normally import it as PD. Okay, so import pandas as PD, so that we can just be using only PD for our computations. All right. So with the pandas, the first thing that we need to do is that the pandas, normally what we do is that the pandas transform our whatever we have. For example, if you have a dictionary, the pandas will transform it to something of a table for us. Okay, it will transform it to be a table where we can use to do all our analysis. So when you import a CSV file, when you have a Excel file, you use the pandas to make it become a table so that you can be able to use. Okay, so it changes, and that is what we call a data frame. It make it a data frame for you. So for example, let's create a list, a dictionary. Okay, a dictionary of a particular data. So let's say data, and we know how to create a dictionary. We use the curly brackets to open. Then we give keys and particular names. Okay, so let's say that the keys, these are the keys. This time around, I'll use only one key to create so many values. So I have like a key like name, and then so the values that I'll create will be lists. Okay, and then I'll say the first one will be, I'll use Alice, and then I have The next one will be Bob. The next one will be, let me use Clara. Okay, Clara. All right. So once I'm done, I'll close this particular list and I'll create the next list, the next key, which is, let's say, age. So then also the same thing. This time around, these are their ages. So 30, and perhaps the next one will be 34. So once I'm done with this, I close the square bracket. Okay, so let me run. So if I check the type of this, it should tell me that this is a dictionary. Good, it's a dictionary. Now, one of the things that we can do is that we can use pandas to transform this to become a table for us. Okay, and it will be a table for us. So the data frame, mostly we use a shortcut like df. The df is just representing a data frame, so that we won't be writing the long of data frame like a table, just kind of a table. So it's just a placeholder, a variable name. So I'll say that this is equal to then pd dot. Okay, I'm using the pandas to transform this particular list to a data frame, to be a data frame. And I'll type data frame over here, pd dot. So I have data. So I'll use the keyword data frame. Okay, and then I'll open a bracket and I'll type the name of the dictionary inside. So once I type the name of the dictionaries inside, it means that my PD is now a table. Okay, so let me run it. And if I come here and I try to display PD, it's now turned to be a table. So look at how nice it has become. It has changed the dictionary that I have to be a table. At first, the dictionary was, this is not a table. If I run the like this, if I only run the table, you see that it's displaying the dictionary. So you can see we have the key and the values inside. But as soon as we are able to use the PD, that is the pandas data frame, we have been able to transform this particular to a table from the name, and then we have the name and the ages. Okay, where, as I said earlier on, these particular numbers are just the indexing. Okay, so we just name it. We have the 0, 1, 2. So this one you can just at the indexing. But these are the key things: the name and then the ages, the age. Okay, so if the dictionary is big with series of keys and then values, once you use the PD, you can transform it to a data type. You can transform it to a table, which will look so nice for you. Okay, all right. Now let's go a little further where we can create a bigger table. Okay, let's look at a bigger table. So before we move on to the next thing, let's just look at a bigger table. So let me create another dictionary. This time around, this dictionary would be like this. I want to create another one where I'll add the city. Okay, so maybe without wasting my time, let me just copy the whole of this one. I'll just want to update this one. So inside this particular one, okay, I can break it down one by one. So I'll break this particular one down like this, and then I'll specify the age. So this one too, I'll break it down like this, so that I can have the next one, which will be city. So that now my values are also going to be a list. The first one will be maybe New York. The second one will be maybe Los Angeles. Okay, Los Angeles, we have that. Something like this. Okay, and then the next one may be Chicago. Then I'll close it. So I have a complete list like this. Okay, once I have complete list like this, I have to run it. Once I run it and I call out the data, it's giving me a dictionary. Okay, it's actually giving me a dictionary. Oh, there should be comma here. Good, good. So this look good. Okay, so you have a nice dictionary like this. So the next thing I want to do is I want to transform this particular dictionary to a table, okay, with pandas. And all that I will do is that I'll use the same command to it. So I have this, and then I want to print into brackets df. So once I run this, it's giving me the list. This is how it's printing it out. Okay, so let me not use the print function assistant. Good. With the print functions, it doesn't print it nice for me, so I want it this way. So you can see that we have a correct table where you have the names, the age, and then the city. Okay, so that is how the pandas help us transform the dictionaries to table. Even if you have a CSV file, that is comma separated files, you can use the pandas to transform it to a table that you can use for your analysis. Okay, that is one thing that it always helps us with. All right, so the next part that we want to look at is we have the matplotlib and then the seaborn. Okay, so we use the matplotlib to do some few computations. We say that the matplotlib is a comprehensive library for creating static, animated, and interactive visualizations in Python. So the matplotlib and the seaborn is just an update of the it's just built on the matplotlib. So let's take them one by one. So you say that the matplotlib is a comprehensive library for creating static, animated, and then interactive visuals in Python. Then it's kind of a low-level library that allows detailed customizations of plots. So when you create a plot, it's such that it can help you be able to customize your plot anyhow you want to do it, okay, to make it more interactive and nice. Okay, so that is about the matplotlib. Okay, so the first thing that we do for us to have access to the matplotlib, we need to install it. Okay, we need to install it just as the way we install the NumPy and the pandas, we do the same thing. So we see that pip, okay, pip install. So pip install matplotlib. Okay, so we have the matplotlib. Okay, so when we run it, it should because I already have it, it should give me that requirement already satisfied. But if you don't have it, this is how you are going to install it. Okay, so okay, it's downloading something for me. Successfully installed. Okay, so it means that I have successfully installed it. Okay, so that is how we install the matplotlib. All right, now after you finish installing, you need to load it. You need to load this particular one. So what you do is import. You use the import matplotlib. Now we have a functions inside the matplotlib. There is a module in matplotlib that we use to do the plotting. There are so many modules in the matplotlib, but one of the modules that we use is the pyplots. Okay, we use the pyplot. The pyplot is a module in the matplotlib library used for creating visuals in Python. It provides the collections of like kind of functions that makes it easy to customize your plots. Okay, so when you want to customize your plot or your line plot and stuff, the pyplots help us do all those things. So the first thing that we need to do is that we need to import that from the matplotlib. Okay, but we say that import, then we type the matplotlib. So we have the matplots dot pyplots. Okay, So we see that we are importing these particular models in the matplotlib. So pyplot as plt, so that we won't be writing pyplot throughout. Okay, so this is how we do. So once we run it, error, it says that no model name pyplot. What am I typing wrong? Import matplots. Oh, okay. Lib is supposed to be, oh, it means I've made a mistake here too. It's B. Sorry. You have the B. Good. It's good. Requirement already satisfied. It's matplotlib, okay? Not the lib, not lib. So here too, you have to change it. Good. So that is what we have. Good. So it's successfully run for us. So the next thing that we do is that now that we have imported the matplotlib, we want to create some common visuals. Okay. So we want to just create some simple visuals, and then we have to get some data. So for example, let me just say that, let me create just a simple data, a list of data. So an array, I'll say that one x contains something like 1, 2, 3 up to 5. So we have this. So we have this, and then y is also equal to the same thing. Y, I want to create something like 2, 3, 5, 7, and then maybe something like 11. So that I'll close it. So once I am done this, now I want to create a plot out of this data, both the x and y. So what I'll do is that I'll use the plt. You see, I said matplotlib dot pyplot as plt. So I'll use the plt dot, and then I'll use the plot function. So you say plot, and then I'll now create s comma y. I want to plot the x comma y. Okay, so let's just run this and see what we see. So you see, this, it has created a nice visual for us, but this is not good. So you want to at least customize this particular visuals. Where we have it, we will give it a title, something like we give it a title, we give it some kind of x and y labels, and then maybe we change the color and do some editing. So inside this particular plot functions, okay, I'll do comma and I'll type color. I want to give it a particular color. This particular color, maybe I can use red or blue. So let me just use blue. Then I'll give it I want it to be like at any point, it should give a particular marker. So I'll say marker. Okay, I'll show you what the marker is a bit. Marker, and then maybe I'll type O. Okay, so, and then the next one is the line type. Do I want it a straight line, or I want it a dotted line? So I'll say line style. Okay, so I have line style. Where's, I didn't type Y, line style. Okay, line style is equal to, then I want it to be, I want this. Now I want to name the x and y axis. So the same thing, plt dot, then I'll say title. First of all, I want to change that, give it a title, and then I'll open parentheses, and inside the title I'll say line plot. Okay, so like this, and then the next one is plt dot. So x label, I'll say x, yes, x label. So x label like this, and then I'll name this one as maybe x axis. Okay, so we have the axis like this. Okay, so once I do this, the next one I also do is that I want to give it the y axis plt dot y label. So this is helping us label the axis. Okay, The Y label is to help us label the Y axis. The X label is to help us label the X axis. And then the title is to help us label give it a particular title. Okay, so here, this one I will say Y axis. Okay, so axis like this and close it. Okay, so when I run this, I run into some error. Okay, it's run all right for me, but module this one has no attributes. X label. Wow. Oh, okay. It's not X. It's not like that. So there are a little bit mistake. So you have the label, not BLEE. It's supposed to be BEL. BEL. That is how it's supposed to be. Good. So this should work for us. Good. So we have it nicely like this. Okay. So this is what is showing for us. Okay. Now, if I want to suppress this text, if I want to suppress this particular text, I don't want to see that particular text. One way I can do is that I can come down here and use the word plt dot show. Okay. So I want to show only this. Then I'll do it this way. So in that case, I want to suppress that. So I'll suppress any text that will want to come before the plot. So I'll suppress. Okay. So So what is happening over here is that we are just trying to create this particular graph, and then what we try to do is that if the color, what this particular one, okay, this particular one is showing is used to give it a title. It's helping us give it a particular title, which is the line plot, where this one, the second line, is helping us get the axis name, okay, that is for the x-axis, and then this part is also helping us get the y-axis as well. So that is what is happening. And then you see, let's take away these things and see something. When we run this particular thing, you can see that we have some things over here, some text appearing before the plot. If you want to suppress this particular text, we use these keywords. So you say plot.show, so that all those texts will be suppressed. Okay, so that is it. So over here, the color is what we show. You can change the color to anything, maybe black, green, yellow, or whatever. And then the marker is showing the O stand for a small circle for all of them. And then the line star, the two hyphens means that we want a dotted lines. Now, if we use, for example, if we want to, the point, if you look at this particular, we have 1, 2, 2, 3, okay, so 1, 2, and then it will put 0 there, okay, so that is how it's move on. Now let's move a bit further, okay, let's move a bit further. So you are just copying the same thing over here, and then you come and paste it here. So once we paste it here, you should get the same thing. So what we have now is that we now have the same thing, but let's change the line to green, and let's change the marker to square. So if you want this particular dot, this one to now turn to square, we use the X, and we want only a straight line. We don't want dotted line, so we use only one of this. Okay, so that is what we have now. Now we want to say that let's add grid line. Okay, so we want to add grid. So what do you want to do? DLT dot. Then we say that grid. And then the grid into a bracket, we say true. So we want to activate grid line. Okay. So we want to activate grid line. All right. So if we run this, it should create a new good. It should create a new plot for us where it's even giving us grid lines. Okay. So that is it. The few changes is we just change the color, we change the marker, and then we also change the line type, and we also activate a grid line. Okay, so it's just the same plot, but we have made some few changes to it. So that is how we are. Now you can notice that all of them we are using the PLT. It's because we have imported the matplotlib.pyplot. Okay, the pyplot, as I said earlier, is just a module inside the matplotlib. Okay, it's a module inside the matplotlib. So we use that to do our visualizations. Okay, all right. Now let's also create another visuals. Okay, let's create two more visuals. Let's look at scatter plot. Okay, this time around, let's create a scatter plot. So we have. So let's just create a scatter plot. So let me put some comments here. So scatter plot. We have a scatter plot. Then we have x equal to. Then let's give it some numbers. So let's say we have something like 5, 7. So these are just a dummy numbers I'm creating. Okay. So it doesn't have any. So just for demonstration purposes. So let me say 4, and then let me add something like 11 to it. Okay. So the next one is y is also equal to. So maybe have something like 99. So let's say these are for marks of some students. We have 86. We have something like 87, 88, 100, maybe another 86, 10, 103, 87 again, 94, and then maybe 78. Okay, so this should help us. Okay, so now we want to create a scatter plot. So in this time around, we don't use the plot function, okay, but we use the plt dot. Because we want to create a scatter plot, we say plt dot scatter. Okay, plt dot scatter. Now then we now specify the axis. So you have the x and then y. Okay, and we want the color. So we want the color to be maybe color is equal to maybe something like, let me use a purple color. Okay, so we have something like purple, and then let me close this. So I want to name the axis. Okay, so because I want to name the axis PL, so let me just go and copy this ones, the axis name over here. So lazy programmers. So we copy this. I don't want the great lines, let me take it away. So here, this time around, the title is scatter plots. Okay. So you have the scatter plots, and then we have the result. So the same thing, this one is going to suppress any outcome that we want to come before will appear before the plot. So if I run this, it should give us Z. It's giving me some kind of error here. The plt dot scatter. We have the x, y, z. So where is the error coming from? X and y must be the same side. Good. Our x and y are not the same. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 7, 8, 9, 10. So our x and y are not the same. So let me add the last one. Good. So because x and y are not the same, of the same length, we had error first. So this is how we have it. This is our scatter plot. Okay. So this is how we create a scatter plot. All right. We also have the bar plots, histogram, and so many other stuff. Okay. So with the, it's just follow the same thing. With that of the bar plots, we use the plt dot bar, and then with that of the histogram, we also use the hist function. We use the hist function to create them. So let's just create maybe let's create a random number that we can create a histogram. Okay, so with a random number that I want to create, I'll just use a random. So I'll say data is equal to, and I'll use the numpy function np dot, then I'll say random. Okay, so I'll say random. This function creates a random numbers. Okay, a random and random dots. So I'll use the rnd, okay, and function, and I'll create a random numbers out of maybe 1,000. Okay, so like this. So now I can create my histogram. Let me copy the same thing over here. Let me just copy the same thing, so that, and then I'll do some changes. So here, instead of the scatter, I'll use what you call haste, like this, to create the, and then here I'll instead of me using xy, because there's no xy, I'll use the name data. Okay, So data, and I'll specify bin. Okay, bin is basically just to the interval. It gives us the interval of the bins, that is the bars. So that is kind of that. And then here too, let me use a different color. Let me use a color like maybe sky blue. Okay, so we have the sky blue. Okay, and then let me just run this and let's see what happens. Okay, it says that was rectangle dot says got an unexpected key argument bin. Yeah, it's not supposed to. It's supposed to be bins. Good. Yeah. So you see, when you do a small error, it will give you an error. So you have to be smart to be able to debug the error. Okay. Let me also add the edge color. Okay. Let me try to add some edge color so that my bars will have a particular edge color. So let's say I have the edge color. So edge color, I'll say black. So when I run good. So the edge color is just giving it the edge to each of the bins. Okay, each of the bins, or let me say the bars. So that is it. Now if I reduce this one, if I reduce this one to maybe 10, let's see what happens. The bars become bigger. So as soon as when you increase the bins, it increases the bars. Okay, depending on the size of your data set. That is how you set that one. Okay, so if your data set is too many, you can set it to 6 depending on how. If only you want to be able to see everything. But if you want to just display a few of them just to give it some average, then you use the smaller bins. Okay, so that is how. Now we are using a random function just to generate some random functions. Okay, some random numbers. Okay, out of 1,000 we are generating some random numbers over there. So that is how we are using the rand functions. So this is how we also create a histogram. With the histogram we use the hist function. And if we want to create a bar graph, okay, with a bar graph we also use the value bar. Okay, we use the value bar to create that one as well. So that is how we create that of the bar function as well. Yes. So that is that. Now the last thing I want to talk about is that the C bond. Okay, with the C bond we say it's just built on, it's just built on top of the matplotlib. Okay, and provide an easy interface for creating complex visualization with less code. So if you want to create a complex visualization with just a less code, that is where we use the C bond. Okay, it's particularly powerful for like statistical data analysis or data visualizations, and work seamlessly with pandas. Okay, so with the help of the pandas and the numpy, you can be able to use the cbonds to create also an awesome visualizations. Okay, so that is that for data analysis with Python, or data analysis in Python, or Python for data analysis. I thank you so much for staying with me up to now. This has been one of the longest tutorials, one sitting, but you have been with me throughout the end. I encourage you to subscribe to the channel, share the link with your friends, and practice all that you've learned so that you master them. Should you have any challenges or difficulties, don't hesitate to reach out, and I will be glad to help you. Once again, remember to subscribe, share with your friends, and invite, and let's all build a community of data analysts together. Stay blessed.